Hey gang, I thought we'd take a little moment to review the process of initially setting up a converged device. Of course, we would begin by heading up to the wireless web GUI, and then often we would want to launch that first wizard that allows us to get the ball rolling and kind of get a default configuration in place. So when we get to this point, of course, then we're going to reiterate, if we need to, the default name and password. Of course, those are there by default. And then we get to some more interesting things. So let me ask you, gang, when we set this up, we have our SNMP system summary here. And you can see that we have the ability to define our location and our contract for our SNMP service. Then we have the idea of an SNMP global trap being enabled or disabled. What does that mean to enable or disable that trap? Come up with an answer, pause the video, and then we'll talk about it together. All right, so our SNMP global trap doesn't actually initiate any particular traps to our SNMP management service, but what it will do is allow us to, as we define various traps at lower configuration level, as those are defined, this says yes, go ahead and send that information out to the management service once that's been defined. All right, then we come in here and we have the ability to define our management port. We see that right here. Gang, what should that management port be plugged into? Pause, and then we'll review it together. That management port is really designed to work as the uplink to the switch, except remember that we're in a converged wireless LAN environment. So really, this would typically be from the access layer to the distribution layer switch that we would want to see. Notice an IP address and network mask are needed. IPv6 is optional, and of course, we can supply the information to relay DHCP. Now, over on the right-hand side here, as we're looking at our wireless configuration, setting up wireless management, what type of device is it that we would expect to see being associated with VLAN 11? All right, we see we have a particular IP address that's been assigned there, VLAN 11. Go ahead and take a moment, and then we will pause, and then we can review this together. Remember, when we're setting up wireless management, this is talking about the access point. So we're going to have a switch, and then plugged onto that switch is going to be the access point. And so our switch/wireless LAN controller, we're defining here that VLAN 11 is the VLAN that should be used to identify our access points here on the other end. This is not the VLAN, in other words, for the clients. That's going to be something separate when we're configuring our actual wireless LANs. Of course, we'll configure our RF mobility definition, our mobility configuration. And then when we set up our wireless LANs, again, we have this wireless LAN ID. I'd like to ask you a question. Is that the same thing as a VLAN ID? Pause, and then we'll discuss it together. Okay, definitely not. A VLAN ID, that's very specific. We'll set that up in order to support our clients. This wireless LAN ID is a local ID number that is used on the controller in order to identify it relative to other wireless LANs that we define. So this is an object identifier. It's locally defined. It has nothing to do with VLAN IDs, though eventually, of course, all of the clients on a wireless LAN will need to be included into a particular VLAN in order for this to be processed correctly, right? But that is a separate process that is not part of what we're not associating that there directly with any particular VLAN. Great job. Of course, if we're pointing to a radius server like ICE, then we would define that next. See that there. We see our ability to configure support for these two configurations. Pop quiz, gang. Which of these, if I were to enable it, would I be enabling as the 5 gigahertz range? Which of those two check marks indicates the 5 gigahertz range? Pause, and then we'll discuss it together. Okay, the 5 gigahertz range, of course, is 802.11a, n, and AC. That's 5 gigahertz communication, as opposed to BGN, which is going to be the 2.4 gigahertz range. Great job. Of course, setting the time and pointing to a network time server is very important. Why is that important? Why is it important to have accurate time on your wireless LAN controllers? Pause, and then we'll discuss it together. All right, when I think about having the correct time on my wireless LAN controllers, two of the key things that come to mind are going to be certificate management. Remember, certificates have a particular date and time for which they are valid, and you don't want those to be considered expired when that's not true, and especially logging. That's another big deal to make sure that your logging information is accurately posted, and that's going to be because you have the right date timestamp on all the information that's in there. All right, once you've gone through that whole wizard, you get to save it, and then you've got, of course, your converged wireless LAN controller up and running and ready to start processing.